Alrighty guys, so here's the video for your P.4 notes. Your objectives are right here. Basically, we're going to be just factoring polynomials of all different types. This is, again, a review lesson. So in P.3, we were multiplying. Now we're going backwards to factor. Remember, we spent a lot of time in Algebra 2 factoring, so this should be a breeze for you guys. A polynomial is completely factored when each of its factors is prime. It's just a little vocab there for you. So to factor each expression, remember removing common factors. First off, we need to look for any GCF, greatest common factor. So in part A, we're just going to pull out a 2x, and then I'm left with a 3x squared minus 2. And I can't do anything more with that, so I'm going to leave it. In part B, my GCF seems to be -4. And I'm going to pull out a -4 instead of a +4 because then I won't have the negative out here in front. So I have x squared minus 3x plus 4. And I don't have any factors of 4 that add to -3. So this is prime, and that's my final answer. And then finally in part C, it's like they've already grouped it for us. So we have an x minus 2 in both terms. This is a term, and this is a term. So we have an x minus 2 in both terms. When we pull out that x minus 2, we're left with a 2x and then plus 3. So go ahead and pause me and try A, B, and C of the next one. I'll go ahead and write the answers so you can check your answers to those. So for this one, we pull out a 5x squared, and we have left an x minus 3. For part B, I'm going to pull out a -3. And then I have 1 minus 2 plus 4x cubed. And then for part C, I have an x plus 1 in common to both terms. And then I have left x squared and then minus 2. So that is GCF, strictly GCF. Now we're going to go on to factoring special polynomial forms. So we have our special ones that can save us a lot of time if we just remember these. So first of all, it's our difference of two squares, or difference of two perfect squares. So let's say we have 9x squared minus 4. If we can break the first term down into something times itself, and we can break the second term down into something times itself, then we can factor it like this right here. So in this case, 9x squared breaks down into 3x times 3x, and 4 as 2 times 2. So we have 3x plus 2 and 3x minus 2. Next, we have our PSTs. Now remember, with our PSTs, some of them have the plus sign right here, and some of them have the minus sign. So I'm going to give you an example of both. This is the double the squash thing, but backwards. So let's say I have x squared plus 6x plus 9. So the thing about PSTs is this sign is always going to be positive, okay? Your first term is going to be a perfect square. Your last term is going to be a perfect square. So I can break my first term down. I can break my last term down. Now I just need to check double the squash. So as long as my double the squash is equal to this term right here, which it is, x times 3 is 3x, doubled is 6x, I'm good. That's a PST. So let's try one with a minus sign. Let's say that I have 4x squared minus 20x plus 25. So I know that 4x squared breaks down like 2x and 2x. Since this right here is a minus, my in parentheses is going to be a minus as well. 25 is 5 times 5, so it's quantity squared. Now I just need to check double the squash. 2x times 5 is 10x. Doubled does give me 20x, so my double the squash is fine. Now I'm going to do the sum or difference of cubes. We did these last year. So let's say I have x cubed plus 8. I'm going to do a sum first. This is where we broke it down x times x times x and 2 times 2 times 2. And then we took these two terms and drew a triangle. So that what's in the triangle is our first factor, so x plus 2. Now we take x times x to get x squared. This sign is always different than your sign in your first parentheses. So since x plus 2, I'm going to have x squared minus x times 2, which is 2x. Then I always have plus on the end, 4, because 2 times 2 is 4. So if we try it with a difference, let's say I have 27x cubed minus 1. That's a 3, sorry. 27x cubed is 3x times 3x times 3x. And 1 is 1 times 1 times 1. So I'm going to draw my triangle. And I would get, I'm running out of room here. I'm going to draw it up here. 3x minus 1 times 3x times 3x, which is 9x squared. Now it's going to be plus, since it was 3x minus 1, my next sign is going to be plus. 3x times 1, which is 3x. And then 1 times 1, which is 1. So that would be my answer for that factor. So now we have some examples. Removing a common factor first. So that's telling us that maybe first there's a GCF and then maybe we can factor it farther. So first I see a 3 that can be factored out. So 3 times 1 minus 4x squared. Now I notice that that is a difference of two perfect squares. So 3 times 1 plus 2x times 1 minus 2x. And remember, multiplication is commutative. So if you would have put 1 minus and then 1 plus, 1 minus 2x and then 1 plus 2x, separate or in the different order than mine were, that's totally fine as well. Okay, B might be a little bit deceiving because you could factor this as a difference of two perfect squares right away, but then you'd have to factor out a GCF at the end. So I recommend factoring the GCF out at the very beginning, like I've preached to you this entire time. So I see a 4 that can be factored out. When I take a 4 out of 100, I get 25. So I have 25 minus y squared. Now when we factor that difference of two perfect squares, I get 4 times 5 plus y and 5 minus y. All right, now we're factoring the difference of two perfect squares that are a little bit tougher than the examples that we might have seen last year in Algebra 2. So I have something squared minus something squared. So that is a difference of two perfect squares. So I'm just going to take the first thing plus y and x plus 2 minus y. Okay? So there's nothing I really can do to simplify that. I can take away the parentheses on x plus 2 because there's no need for them. So I have x plus 2 plus y, and then x plus 2 minus y. So it's just like yesterday when we were going backwards in multiplying. For part B, we can break this down. 16x to the fourth gets broken down like 4x squared and 4x squared. So I have 4x squared minus 9 and 4x squared plus 9. Now, hopefully you notice that this can be broken down and factored even more, because that is also a difference of two perfect squares. So this is 2x plus 3 times 2x minus 3. And then we still have the 4x squared plus 9. Because remember, a sum of two perfect squares cannot factor. And then you guys try part C. The answer to part C should be x minus 1 plus 3y squared times x minus 1 plus 3y squared. I know I had to squeeze that in. Sorry. All right, factoring perfect square trinomials. Now I know it tells you that they're perfect square trinomials here, but you're not always going to know, so remember to just check that to make sure. So remember, we break down the first one, we use this sign, we break down the second one, and we square the binomial. Now just to check, to get you guys in the habit, when we double the squash, so x times 5 is 5x, doubled is 10x, which matches 10x, that middle term. So when we try it on B, break down the first term, we get 4x. It's a plus. Break down the last term, we get 3. Square the binomial. When we double the squash, 4x times 3 is 12x. When we double it, we do get 24x. So we are good to go. Then you guys try C. It should be 3x minus 5 quantity squared. All right, factoring a difference of cubes. I'm going to do B. I want you guys to try A. So I'm going to do B. So 64x cubed is like 4x times 4x times 4x. And 1 is 1 times 1 times 1. So when we do the triangle, we get 4x minus 1. Now we multiply 4x times 4x to get 16x squared. This sign is plus because my first sign was minus. Then I take 4x times 1 because that's what's in the triangle, so 4x. Then the last sign is always plus. I take 1 times 1 to get 1. And remember, the trinomial that results when you factor a sum or difference of cubes can never be factored further. So hopefully you pause me and try A, but your answer should be x minus 3 times x squared plus 3x plus 9. I'm going to do B on example 6, and then you guys can try the rest of them on your own. But B, 3x cubed, I noticed, is not a perfect cube. So I'm like, what if I can factor out a GCF first, which is what I should always check for anyway. So when I factor out a 3, I get x cubed plus 64. Now I'm ready to break it down. So x times x times x, 4 times 4 times 4. Make my triangle. Remember, the 3 gets carried down to my final answer. So I have 3 times x plus 4. Then I have x times x, which gives me x squared, minus, since my first sign was plus, x times 4, which gives me 4x. I got that from the triangle. And then 4 times 4 to give me plus 16. So that's my final answer there. So I'll quickly write in the correct answers in case you tried them on your own. So on A, we have y plus 2 times y squared minus 2y plus 4. On C, we have x plus 6 times x squared minus 6x plus 36. And then on part D, there was also a GCF of 5. So you should have gotten 5 times y plus 3 times y squared minus 3y plus 9. Okay, finally, trinomials with binomial factors. So these are trinomials in the form y equals ax squared plus bx plus c. And actually, they're not even equations yet, they're just expressions. So when the leading coefficient is 1, remember we use the x method. And when we have a leading coefficient that's not 1, we use the AC method. Last year, I sometimes called this the rainbow method. So if you remember that, that's what we use. Okay. So these are just your normal factoring that you're used to. So I'm going to go quite quickly through these. So A, we need 2 factors of 12 that add to -7. And I'm hoping that you guys are saying -4 and -3. So we have x minus 4 and x minus 3. Go ahead and try B if you want. But we need 2 factors that multiply to -6 and add to 1. Hopefully you're seeing +3 and -2. So we have x plus 3 and x minus 2. So those ones are pretty easy. Remember, always look for a GCF too. That's always our first step. All right, now on to the ones that are a little bit harder when the leading coefficient is not 1. So this is when we use the rainbow method. So we say 2 times 15, or -15, that's -30. So I want 2 factors of -30 that add to +1. And I'm like, okay, 6 and -5 multiply to -30, but add to +1. So I'm going to rewrite x using a 6 and a -5. So I rewrite it as 2x squared plus 6x minus 5x minus 15. And remember, I'm going to group these. So I put the 6 by the 2 because they're 6 is divisible by 2 and 15 is divisible by 5. So you'll see why. So I'm going to group them like this. Out of this first group, I can pull a 2x, and I get an x plus 3. Out of this second group, I can pull a negative 5, and I get x plus 3. So I get x plus 3 times 2x minus 5 as my answer. I'm going to do C, and then I'll let you guys try B on your own. So for B, I do rainbow. So I need 2 factors of 12 that add to 7. And I'm going to use 4 and 3. So I'm going to rewrite 7x using 4x and 3x. Now, 4x and 3x will both be divisible by 12x squared. So it doesn't matter what one you put next to the 12x squared in this case. Sometimes it doesn't matter. So I'm going to rewrite 12x squared plus 4x plus 3x plus 1. Now I'm going to group. So out of the first group, I can pull a 4x, and I'm left with 3x plus 1. Out of the second group, all I can pull out is a 1. And I'm left with 3x plus 1. So factored, I get 3x plus 1 times 4x plus 1. And then hopefully you pause me and try B for yourself. But you should get x minus 1 times 2x minus 3 as your answer for B. Finally, our last type of factoring is factor by grouping. And this should be pretty easy because we were just doing it up here when we grouped. Like in part A, 2x plus 6, 2x squared plus 6x, and negative 5x minus 15. In these, they have it grouped for you. You're going to do the first and second and the third and fourth. Sometimes that might not be, so just be careful. So out of this first group, we can pull an x squared, and we're left with x minus 2. So remember, we want x minus 2 when we pull something out of this second group. So I'm going to pull out a negative 3, and I get x minus 2. So I get x minus 2 times x squared minus 3 as my answer. Pause me and try this one on your own. But I'm going to group again like this. So I'm going to pull out an x squared, and I get x plus 1. So remember, whatever I pull out of here, I want to be left with an x plus 1. So I'm going to pull out a negative 5, and I am left with an x plus 1. So I get x plus 1 times x squared minus 5. And that is my answer. And remember, you can always multiply your factored answers in order to check to see if you were spot on. Okay, so just as a little summary, guidelines, steps for factoring. First, always we check for a GCF. You never know when one could show up, and you might be struggling to factor something because you're forgetting to factor out a GCF. Next, we're going to check for any special cases. These are on page 23 in your notes. Those are your difference of two squares, your PSTs, your sum of cubes, difference of cubes. If we don't have any GCFs or we've taken care of step 1, we've checked for special cases, then we're either going to use X method or AC method. Remember, X method is if A is equal to 1. AC method is if A is greater than 1. So if you have a coefficient on that x squared term, you need to use this rainbow method. Also remember, step 3 is for trinomials. Trinomials only. Trinomials have 3 terms. Finally, for step 4, we're going to factor by grouping only if more than 3 terms. So if you have more than 3 terms, you need to factor by grouping after you check for GCF. GCF always comes first. Okay, so after this video, you should be able to complete your P.4 homework. So stay tuned. Look on Google Classroom for directions on how to submit that. Reference this video if you need. Message or email me if you need to, or hop on Google Meet. But please let me know if you have any questions.